Even Neptune's hard to follow, and it takes 165 years for it to orbit the sun. And everyone take a look at Sedna, way off in the distance. It's just barely crawling along as the centuries go by. When Mike and his team discovered Sedna with the 48-inch telescope at Palomar, it was in the part of its orbit closest to the sun. Now, Sedna only spends about 200 years out of its 11,000-year orbit, close enough and therefore bright enough to be detected with a telescope that size. Now think about that. Out of the 110 centuries it takes Sedna to orbit the sun, Mike and his team happened to find it during the two when it was close enough to see. Could be they just got lucky. But what if there were lots of Sedna-like objects out here just waiting to be found? That means in any given century there'd be at least a handful close enough to be detected with a 4-foot telescope. Well, as it turns out, there are several objects out here with orbits like Sedna, and it's these objects which are showing us evidence that there might be a true ninth planet out here. Now, we can see the evidence if instead of looking at the entire Kuiper Belt, we narrow it down to specifically Sedna-like objects whose orbits extend the farthest from the sun, so they're the least affected by the gravity of the 8 planets. And notice anything curious about those objects? See how their orbits are all kind of lined up on one side? It's not exact, but they're all pointed more to the right and not the left. Well, there's only 1 in 10,000 chance that the orbits would all be aligned like that. It's stranger still is that over time, these orbits should all precess. They should all spin around the sun at different rates, as we're seeing right now. So even if they started off aligned, they wouldn't remain that way over the next few 100 million years, unless something keeps them aligned. Something massive, something very far from the sun, and we call that something Planet 9. Now, this computer simulation will show how Planet 9 affects the orbits of the distant